Hi, this is Phil Hinton and welcome to our guide to 3D TV. We all know that 3D has been around for a long time. It started way back in the late 19th century with experimental photography, and we've seen films made in 3D in the 1950s and 80s using the anaglyph system. This used red or green or red and blue glasses, and the films used this colour system with two images slightly apart to give the 3D effect, and if we are honest, the system didn't work and gave some people a headache pretty quickly. So what is this new system of 3D all about, and why should we care? There are many cynics out there who say it's all about making money, and they wouldn't be far from the truth. It's no secret that 3D films are making the film studios some big money, and with Avatar being a global smash and the highest grossing film ever, it looks like 3D is here to stay. So what about the home systems, and why should we be bothered about 3D TV and 3D Blu-ray? There have been a lot of questions on the forums about this new 3D technology and how it works. So let's have a look at the two 3D TV systems coming to our homes, as well as answering some of your questions. There are two approaches being used by TV manufacturers to show 3D images. They are called active and passive systems, and this refers to how they display the 3D content and the glasses that are used. No, there is no format war between passive and active TVs. Each will display 3D Blu-ray and 3D broadcast systems, just in slightly different ways. Well, no, every 3D TV that is launched should also be a good quality 2D TV and does the normal job of showing normal TV programming and Blu-rays as your existing HD TV does. The 3D side of the TV should be about watching certain films and TV programs that are broadcast or shown in 3D now and again, and this should certainly be something of an event for the whole family. As it exists in some TVs at the moment, the conversion of 2D programs and films by the TV's processing chip is rather like the frame interpolation systems in some TVs now. What that means is it's guessing what things should look like and then giving you its idea of what the chip thinks is right. So in short, if you want 3D that works as it should and give you a genuine experience, stick to material that's shot in 3D and not converted would be the best advice we could give you for total enjoyment of the 3D sensation. We have seen some 2D films made into 3D after filming lately, and the feedback has been less than positive. So don't expect a chip in a TV transferring 2D to 3D to work very well at all. Okay, so let's look at how the content is produced first of all, and then how the TVs work. Let's start with Sky and its broadcast system. You may be wondering how the 3D signal is broadcast, as 3D uses two slightly offset images. You may have heard of side-by-side and sequential methods of 3D content playback. This refers to how the left and right eye images are displayed and how the glasses work. Each delivery system, whether it's side-by-side or sequential Full HD, will work on each type of TV, be it active or passive. Side-by-side refers to how the broadcast signal is transmitted and received. The system broadcasts the left and right eye images side by side. These are squeezed horizontally to fit the two images within the frame, and vertically each eye image is slightly different. The left eye, for example, will use the even picture lines, and the right eye will use the odd lines. This approach uses the same transmission bandwidth as one HD channel, so images broadcast side by side in this method will display as side by side on a normal Sky HD box. A normal 2D TV will also show this broadcast side by side image. However, the trick is not in the Sky box, but rather the new 3D TVs. The video processing in the TV when the 3D button is pressed blends the two images into one 3D image. The odd lines are the right eye and the even lines the left eye. method used for 3D Blu-ray differs from the broadcast side-by-side method, as it has technically more picture bandwidth available on the disc. This system uses full HD images for each separate eye, one after the other. This is done quickly and in most cases uses 60 frames per second. So frame 1 is left, frame 2 is right, frame 3 is left, frame 4 is right, and so on. So 30 frames left and 30 frames right. Let's look at passive TVs first. So why are they called passive? Well, it refers to the glasses that are used to get the 3D effect. These do not require power and use what is called polarization to get the separate images to the correct eyes. The passive TV has an expensive polarized filter on the screen that corresponds with the filters in the glasses. So, for example, the left eye image is seen as it is filtered clockwise, and the glasses left eye is also filtered clockwise, so it shows that image. The right eye is counterclockwise filtered, and again the right eye on the glasses is the same, sending that image to the right eye. This then tricks the brain into seeing a 3D image. The passive TV is usually associated with side-by-side broadcast, such as the system used by Sky, but it will also work with 3D Blu-ray delivery systems. Active TVs use the framed sequential method of showing images in 3D. This uses powered shutter glasses and an infrared transmitter to send the sync code from the TV to the glasses so the shutter works correctly. As the left eye image is shown, the active glasses block the right eye by using a shutter. Then it opens when the right eye image is shown and the left eye closes. When it is synced correctly and at high speed, the effect again tricks the brain into seeing a 3D image. Again, this active system is usually associated with the 3D Blu-ray sequential system, but it will work with the broadcast side-by-side system no problem. Again, there are differences and some drawbacks with the different TVs. For example, with active systems, the TV has to work quickly and show each separate left and right eye image in a time of 1/60th of a second. This is where some drawbacks and image issues may be seen. LCD and LCD LED screens can suffer from what is called crosstalk. This is where the images are not quite fast enough at changing, and some of the previous image may still be seen in the wrong eye. This leads to an effect that looks very similar to the old ghosting effect of analog TV transmissions and is called crosstalk. Plasma displays, because of their natural faster response times, can work quicker and should cut down on this effect. Panasonic has even gone one step further and introduced faster phosphors in their 3D plasma that almost eliminates the issue altogether. So it's important that if you're looking at buying a 3D TV, you look very carefully at each model and look for the positives and negatives before buying. And of course, you should read our full reviews on AV forums once the TVs have been fully tested. And that wraps up our quick look at 3D TV technology. If you have any further questions, please add them to this video's post at avforums.com and we will be sure to answer them in our next 3D tutorial. Thanks for watching.